I've shown you a bifurcation diagram. So here's a parameter, and here are the fixed points present in a system. And I've simply told you that there's some way to make the bifurcation diagram look like this, where we have a saddle node bifurcation down here, and another saddle node bifurcation up here, and somehow these branches are connected, so that it's possible that depending on the value of the parameter h, there's a low stable fixed point, or there's a high stable fixed point, or for some range of parameters, there's two different stable fixed points, and the one that we land in depends on the history of our action through the system. And so now, how do we get this kind of situation? I'm going to continue to think about our velocity as coming from a difference of two functions, so that we're looking at the intersection of two functions in our reasoning. So we're trying to generate bistability, and I'm going to draw f1 and f2. f1 is going to be a function that has something that looks kind of like a threshold effect. The function doesn't change too much with x for a long time, and then once x gets close to some value, it changes pretty rapidly, and then it saturates. And our second function is just going to be a tilted line, and the intercept of that line is going to change as we change our parameter. And so let's say actually the intercept moves down as our parameter moves up. So here we are, let's say, with the parameter set to 0, and we have one fixed point. It's at this intersection, and let's see, f1 is greater than f2, so we're positive over here, which means we're negative over here. And so this fixed point is stable, and it's somewhere at negative x. So here we are at negative x with our stable fixed point. And we're going to change the parameter a bit. We're going to increase it. And that's going to shift our line. So maybe it's, okay, they should be parallel. I'm not so good at this. So they're right around there. And so the x value of the fixed point hasn't changed that much, but it's increased a little bit. And then we're going to shift it down even more. And this is the moment where we're going to pretend that a tangency just happened there. My drawing isn't so good, so it didn't exactly happen. But when that tangency happens, that's a saddle node bifurcation that's happening. And so at this value, this kind of x, a saddle node bifurcation has just happened, where stable and unstable branches are going to be born. And this lower stable point continues to exist. And then we try another value. And at this value, there are now three fixed points. There's the one coming off from this that will continue to exist at this upper intersection. There's this one sort of in the middle. It's going to be unstable, and that's because fixed points go stable, unstable, stable. And then our lower fixed point continues to exist. But you can see it's not going to exist for that much longer. As we continue to shift the line, we're going to go through another saddle node, and this lower point is going to disappear. So for now, it still exists. And there's also an unstable one that's already been born, and actually that is probably quite a bit lower in value. Okay, and then we shift a little bit more, and we go through that other saddle node. So that happens, say, right over here. We go through this saddle node, and after that saddle node happens, the lower stable point is gone, and only the upper one exists. And so having this kind of threshold effect combined with a pretty simple straight line results in a bifurcation diagram that exhibits the bistability that we were interested in. There are other geometric ways that we could create bistability. The important thing is that as we change a parameter, we change from having one intersection to multiple intersections. So here's an example that happens in the book where there's a curve that looks like this, and we have a line, and we're going to transform this intercept as we change our parameter. So you can see that there's a single fixed point, but at this point we've just had the saddle node, And then as we continue, we now have the three intersection points. And if we continue enough, okay, this is getting kind of absurd. This is going off the screen where this intersection happens. But I think you can see that as we continue enough, we have a scenario that leads to a bistability bifurcation diagram. Okay, so we had a fixed point that was up here, and as we continued to change the parameter, it increased in its position, and then a fixed point was born down here at some point. And things looked maybe a bit like that. And this lower fixed point kind of went off pretty quickly. So this fixed point was shifting upwards, upwards, upwards until it disappeared. This fixed point was born down here and was shifting upwards, upwards, upwards as well until it disappeared. And this fixed point was born here and was shifting downwards and doesn't shift actually too much. And so that also creates bistability, where when we're over here, we're on this upper line, and we could be dragged along and fall off it. When we're down here, we're on this lower line and could be dragged along and fall off it. And there's this region that's bistable in the middle. So far, we've really only thought about what happens when we're adjusting a single parameter. I'd like us to go back to that first bistability example, and I'd like us to think about what happens if we had two parameters that we could adjust. And so the first parameter that we've already talked about is we were adjusting the axis intercept point of this line. But what if we had a second parameter and it allowed us to adjust the slope of the line? So one of our parameters adjusts the intercept point and the other adjusts the slope. We know what happens when we adjust the first parameter. That was our h parameter. And it created that bistability picture where we have a saddle node bifurcation here and another one there. But what about if we adjust the slope? Well, let's try to figure out what this diagram looks like as we change h, but for a few different values of the slope, which we're going to call r. So now we have this new value of the slope. I'm going to call it value r2, and this value is going to be value, this axis label is x, but it happened at value r1, and this axis label is x, and it happened at value r2. And so now as we shift this up and down, we're still getting our bistability, I think, but we're barely getting it. Those two saddle node points are really close together, and that's because with the steeper angle, we become tangent to this one only very briefly before becoming tangent to that one. So these two come into existence, and just a little bit later, those two annihilate with each other, and we're left with just a single point. And if we adjust the slope so that it's even steeper, so let's look at a steeper case. Now as we shift along, okay, so this is R3, and we're varying h again. And now as we shift along, there's actually only there's a smooth transition between what used to be two separate fixed points, because we simply just have one intersect. Our slope is so steep that there's only one intersection point the whole time. And so changing two parameters, as we get a different bifurcation diagram for each value of the second parameter as we continue to vary the first parameter, and we can try to combine both of these variations, varying this first parameter and also varying the second parameter, into a single bifurcation diagram. So I'm going to try that. So now we have three axes. We have the values at which the fixed points happen. We have h, the parameter that we were used to, and we have r, the one that we're changing. Okay, and so at some value of r, we have that bistable bifurcation diagram. And then at some other value of r that's kind of way back here, we've lost the bistability, and there's some connection between these two pictures. And it's hard to draw nicely. So let's see, I'm going to shade that in a little. I'm going to shade this overhead. I'm going to shade in there. And I'm actually going to make our unstable branch a solid line so that we can see where it is. Okay, so I don't know that this picture makes that much sense, but what's happening is that if we're at this particular value of r, we have that bistable bifurcation diagram. And if we're at this particular value of r, it's still bistable, but it's a less bistable thing. And if we go all the way out to this value of r, we've lost our bistability. And so this is a two parameters varying to create this bifurcation diagram. And this picture is called the cusp catastrophe. Oh, there's no r there. And the cusp point is the point where we transition from having the two different saddle nodes to having just a single saddle node as we change r. And then the catastrophe is this idea of bistability, that if h is getting changed while we're out at this value where we're in the bistable zone, then we go through this jump, and that's like a catastrophic change in our value of x.